Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 3-6 Extra Practice Number 2 solutions on features of rational functions. For this problem, we're trying to figure out the intercepts, asymptotes, and holes for this function, if such exist. So this looks like we could factor the denominator, but it's not going to allow us to cancel anything out, so we'll hold off on doing that until a little bit later. Let's go ahead and find the x-intercepts to start with here. So for that, we need to zero out the numerator. Unfortunately, the numerator is not a variable, it's just 3. I mean, we could write 3 equals 0, but that's not even true. So there actually is no x-intercept for this one. For y-intercepts, we have to plug 0 in for all the x's in f of x. If we do that, we still have 3 in the numerator. In the denominator, everything zeroes out except for negative 6. So we end up then with negative 1 over 2 if we reduce that. Moving on to vertical asymptotes, these are going to be x values that zero out the denominator. So while we're zeroing out the denominator, it would be helpful to try factoring at this point because we're going to have to solve for x anyway. So we need factors of negative 6 that add up to the invisible 1 that's next to the x there. So that would be negative 2 and positive 3, x minus 2, x plus 3. And if we set all of that denominator equal to 0, we see that x equals 2 and negative 3 are the two vertical asymptotes that this graph has. Moving on, holes, looking for those. Since no factors got canceled out from the original, we don't have any holes here. For horizontal asymptotes, we see that we have a bottom-heavy function. The degree of the denominator is much higher than the degree of the numerator. Since we're bottom-heavy, that means we automatically have a horizontal asymptote of y equals 0. For this one, we're trying to get the features of this rational function here, f of x. So it looks like I could probably factor the numerator, and normally I would, but doing so is not going to let me cancel anything out. I can see that pretty easily here. So let's just go ahead and start analyzing this thing, and if we have to factor it later on, we will. So for x-intercepts, we're trying to find things that zero out the numerator. So let me set negative 2x minus 6 equal to 0. And then if I add 6 and divide by 2, 6 over negative 2 is going to give me negative 3 for my x-intercept. For the y-intercept, I have to plug 0 into f of x and see what comes out of there. So substituting 0 for all the x values in that function, all that's left when I zero things out is a negative 6 over negative 1, which I can reduce to just positive 6. For vertical asymptotes, I'm trying to zero out the denominator of x minus 1. So if I set that equal to 0 and solve it, I get x equals 1 for a vertical asymptote. Since there's no common factors that got canceled out, when I'm looking for holes, I'm not going to find any here. No canceled factors means no holes. For horizontal asymptotes, looking at my original function at the degree of the numerator and denominator, they are the same degree. They're both linear. Both x to the first power is the highest exponent. So then I take the ratio of the coefficients of the lead terms, negative 2 and an invisible 1. Since it's the same degree then, I can write negative 2 over 1, and then I'll just reduce that to negative 2 for my horizontal asymptote. At this point, we're going to try analyzing this rational function for intercepts, asymptotes, and holes. And I could try factoring the numerator, but it's not going to let me cancel anything, so I'll probably do it anyway in a minute, but let me just hold off now on that thought. So for x-intercepts, I need to zero out the numerator, and now I see, okay, it is going to make sense to factor this thing out because I'm going to need to solve for values of x that make this numerator 0. So factors of negative 8 that add up to negative 2, that would be, let's see here, positive 2 and negative 4, so x plus 2, x minus 4, I can factor that numerator into. And I'm trying to zero that out to make the whole fraction 0. So I see that that's going to happen at x equals negative 2 and positive 4. Next, for the y-intercepts, I plug 0 in for all the x's. If I do that, I end up with just negative 8 in the numerator, but 0 in the denominator. Since I'm dividing by 0, that's actually undefined, which means I have no y-intercept. It doesn't touch the y-axis at all. Okay. Well, let's move on to vertical asymptotes then. So that's going to be x values that zero out the denominator here. If we set 3x equal to 0, we very quickly see that x equals 0 is our vertical asymptote. For holes, There's no common factors that got canceled, so there's no holes for this graph. For horizontal asymptotes, we have, looking at the degree of the original function, this is a top-heavy function. We have x squared on the numerator versus just x to the first in the denominator. So that means there's no horizontal asymptote, but there is a slant asymptote. Now to find this, we have to divide the numerator by the denominator. Since we don't have a binomial down here, we don't have to use synthetic division. We're just going to divide each of these terms individually by 3x and see what it reduces to. So we'll have x squared over 3x minus 2x over 3x minus 8 over 3x. Going through and reducing, for the first term, the x's cancel, at least one of them does, so we have x over 3, which I could rewrite as 1/3 x if I wanted to. For the next one, the x's cancel completely, so we just end up with negative 2/3. And for this last one, since we have a higher degree in the denominator, as x approaches very large numbers, which is what this slant asymptote is really getting at, this fraction is going to just kind of reduce to 0 and become insignificant, and really we don't have to worry about it. So really our slant asymptote is just y equals 1/3 x minus 2/3. Before I dive in and try to analyze this rational function, it's looking like I might be able to factor that denominator and just maybe cancel out some common factors. I don't know, but it's worth trying. So I can definitely take a negative 2 out of everything in that denominator, leaving me with x squared minus 2x minus 3. And now numbers that multiply to negative 3 and add up to negative 2, that would be 1 and negative 3. So I can write x plus 1 and x minus 3 along with the negative 2 that's already down there. And hey, look at that. The x plus 1s here are going to cancel. So I can turn this into 1 over negative 2 times x minus 3. All right, so that's going to be very helpful as we go through these different features. The x-intercepts, for example, I need to set the simplified numerator equal to 0 and try to zero out the fraction that way. Unfortunately, I just have a 1 up there left over, and if I write 1 equals 0, that's not actually true. 1 can never equal 0, so this means there are no x-intercepts. Moving on to y-intercepts, this is where what I get if I plug in 0 for all the x values in the original. So if I do that, we see that we just end up with a 1 in the numerator. Denominator, all that's left over after all this gets zeroed out is a 6. So we have 1/6 for the y-intercept. For vertical asymptotes, these are x values that zero out the reduced simplified function. So taking a look here, we take our denominator that was left over after canceling, negative 2 x minus 3, and set that equal to 0. And then we see that 3 is the value of x that zeroes that whole thing out. So we have a vertical asymptote at x equals 3. Next, for holes, those are x values that would have made the original undefined but not the simplified. So basically this common factor that got canceled out gives us a hole. X plus 1, if we set that equal to 0 and solve, that'll get us the hole. That's going to be x equals negative 1 for the x value of the hole. And that's all we're really looking at on these. Now for the horizontal asymptote, we see, looking at the degree of the original function, we have x squared downstairs versus just x to the first upstairs. So this is a bottom-heavy function, which means we automatically have a horizontal asymptote of y equals 0. For this rational function, before I go ahead and start analyzing all this stuff, I should probably try factoring and canceling out common factors. It looks like we can definitely do some factoring to start here. So in the numerator, I need numbers that multiply to 3 and add up to 4. So we'll have x plus 1 and x plus 3. That wasn't so bad. In the denominator, I need to multiply to negative 6 and add up to negative 1. So x plus 2 and x minus 3 is what I need down there. Now, I feel like I ought to be able to cancel some things out, but I just can't. Like the x plus 3 and x minus 3, that's close, but not close enough. They have to be exactly the same. So I'm just going to move on and start analyzing everything, starting with the x-intercepts. But if nothing else, at least this is broken down a bit, so it'll make my job a little bit easier moving forward with all these different tasks. So for x-intercepts, I need to zero out the numerator of my function. So I've already got this factored, x plus 1, x plus 3. I just need to set that equal to 0. and solve for the x's. So zeroing out the first parentheses, we have x equals -1. For the next one, we have x equals -3. Those are our two x-intercepts. For the y-intercept, I need to plug 0 in for all the x values, and it's best if I do this in the original function here. I could do it in the factored version, but might as well go with the original, because if you do it in the original, we happily are able to zero out pretty much everything except for a 3 in the numerator and a -6 in the denominator, and I can reduce 3 over -6 to -1/2. Moving on to vertical asymptotes. For this, I have to zero out the denominator. So I've got x plus 2, x minus 3 equals 0. Since I've already got that factored, I can very easily see that x equals -2 and +3 are going to make my denominator 0. So those are my two vertical asymptotes as x equals those constants. For wholes, nothing actually got canceled, so there's no holes on this one. For horizontal asymptotes, looking at the original function, I have the same degree. I have an x squared over an x squared as the highest exponents. So we're going to take the lead coefficient ratio as the horizontal asymptote. So we have a 1x squared and a 1x squared. So y equals 1 over 1 is the horizontal asymptote. And again, we're doing this because we have the same degree. We take that ratio of coefficients. And I can reduce this to 1, and then I'm done. Before I try finding all the intercepts, asymptotes, and holes for this function, I think it would be helpful to try factoring it, and maybe I'll be able to cancel out some common factors. I don't know, but it's worth a shot. So in the numerator, x squared minus 16, that's the difference of two squares, so I can square root that and put that in a plus-minus parentheses. So x plus 4 and x minus 4. Downstairs, we need numbers that multiply to -4 and add up to -3. That would be x plus 1 and x minus 4 for my factors. And, yep, I see here that I can cancel those x minus 4s. So I've got x plus 4 over x plus 1 for my reduced fraction here. All right, now that we've got that, let's go ahead and analyze everything. For x-intercepts, I need the simplified numerator of x plus 4 to equal 0, so I can zero out the whole fraction. Because if I zero out the whole thing, that means y equals 0, and that's what's going on the x-axis is y equals 0. So subtracting 4 here, we get x equals -4 for the x-intercept. For y-intercepts, I need to plug 0 in for all the x's in the original function. Doing that, I notice that I'm now left with -16 over just -4, which I can reduce to +4. For vertical asymptotes, those are going to be x values that zero out the simplified denominator here. So simplifying was a really good call there. So if I set x plus 1 equal to 0, I see that I have a vertical asymptote of x equals -1. For holes, those are x values that zero out the original but not the simplified function. So basically your canceled out factors give you the holes. So if I set x minus 4 equal to 0, I see that I have a hole at x equals 4. And then finally for horizontal asymptotes, I see looking here that we've got x squared over x squared. We have the same degree for numerator and denominator. That means that my horizontal asymptote is going to be the ratio, the fraction of the coefficients of those x squareds. So 1 over 1, which I can actually just reduce to 1, and done.